Hello everyone, and welcome to the third video on graphs. And the focus in this video is on the concept of slope. Now, what is slope? It's a measure of how the value of one quantity changes when the value of some other quantity changes. And when we talk about how things change, we can think in terms of how much they go up by, or whether they get multiplied or divided by a number. So things can change in different ways. Slope specifically talks about how the value of a quantity changes as a measure of how many times it's faster or slower than the change in the value of some other quantity. So we write the equation or the relationship as change in the value of Q2 is equal to some number times change the value of Q1. To give you an example of what this means, let's suppose that m has a value of 2. M is a constant. So for a given problem, its value will not change. Now in this case, we have the change in the value of Q2 is equal to 2 times the change in the value of Q1. So basically what we are saying is that Q2 changes twice faster than Q1. As an example of that, suppose that delta Q1, change in the value of Q1, is 3. Now, please differentiate between the actual value of Q1 and the change in the value of Q1. What we are talking about here is how much Q1 changes by. The actual value can be whatever it wants to be. It can be, so here we are talking about Q1 changing by 3. The actual value of Q1 could be 10, in which case a change of 3 means that it goes up to 13. The change in Q1, the actual value of Q1 can be negative 2. And in that case, going up by 3 means that it gets to 1. So the actual values of Q1 are not what we are talking about here. What we are talking about here is how much it changes by. And if Q1 changes by 3 units, Q2 changes twice faster. Q2 changes by 6 units. And if Q1 changes by, let's say, 4 units, Q2 still changes twice faster. It will go up by 8 units. So every time Q1 goes up by 4 units, Q2 will go up by 8 units. And if Q1 goes up by 3 units, then Q2 will go up by 6 units. And you can do this for any number, even 0. If Q1 doesn't change, then twice 0 is 0, so Q2 doesn't change. And also for negative numbers, if Q1 changes by going down by 3, then Q2 will go down twice faster, by 6. You can even use fractions. So if Q1 increases by a half, then Q2 increases twice faster, by 1. You can use decimals, you can use any number that you want for delta Q1. And so this is what we are talking about. The value 2 is called the slope in the case of this problem. Okay, now the question is, how do we compute slope? So how to find slope? And of course we can use its definition. We said that change in the value of Q2 is equal to m times change the value of Q1. And if we rearrange this equation and solve it for m, then we have to take delta Q1, change in the value of Q1, and divide by it on the other side, because it's being multiplied by here. So we end up with m is equal to delta Q2, and then divide by delta Q1. And this becomes the kind of equation that you can use to find m, the value of m. In order to do that, you have to find 2 sets of related values. So you can find out what the change in Q1 is, Q2 is, and then find out what the change in Q1 is, and then you divide the 2. Now I'm going to explain how that can be done using an example. So let's say that we want to find the slope of the line d is equal to 100t and discuss its significance in the context of the problem. To give you the context, the equation d equals 100t is an equation that tells you how far you go after some time has gone by if you drive at a speed of 100 kilometers per hour. So for example, if you drive for 1 hour, you will cover 100 kilometers. If you drive for 2 hours, because you're driving at 100 kilometers per hour, 100 kilometers every hour. If you drive for 2 hours, then distance becomes 200 kilometers and so on. So we would like to find the slope of this relationship, and also explain why is it so important to know about it. Okay, the graph of this equation is here. So we have d is equal to 100t with time being greater than or equal to 0. And basically what we are talking about is that after an hour you will have driven 100 kilometers. So you will be here on the road. This is the road, the d-axis. And after 2 hours you will be here. You will have driven 200 kilometers, and so on and so forth. Okay, so in order to find the slope, we need 2 points, and I will explain why in a minute. The short of it is that we need to find change in the value of d and change in the value of t, and for that we need 2 points. Okay, so let's find 2 points on this line. And to begin, I'm going to start with t equals 2. I can pick any value that I want for t, of course. It doesn't have to be 2, but one of the points will be at t equals 2, and that will be this point. We find the value of y, of d in this case. So d is equal to 100t, and with t being equal to 2, then d is equal to 200 kilometers, and therefore we have 1 point, which is p1 at 2 and 200. And this point is shown here. The point is at 2 and 200. Okay, let's find another point. And this other point will be at t equals 5, and that point will be here. And at t equals 5, of course, we have d is equal to 500. But of course, we can use the equation to get an exact value to be certain. So d is equal to 100t, and with t being 5, we end up with 100 times 5, and d becomes 500 kilometers. So our second point is 5 and 500, which is this point. Okay, so we have our 2 points. Point 1 at 2 and 200. Point 2 at 5 and 500. All right, now the slope is equal to change in the value of d divided by change in the value of t. The vertical value, quantity will always go on top. So delta d divided by delta t. If we think about what delta d is by looking at the graph, we notice that we're talking about how much d, the distance that we covered, changed by as we went from point 1 to point 2. And if you think about it, when we were at point 1, we were 200 kilometers. We had driven 200 kilometers. And when we got to point 2, we are at the point 500 kilometers. So we went from 200 to 500. The change in the value of d is 300. It's this distance. And so we can show it over here. This corresponds to the change from 200 to 500. This is your delta d, change in the value of d. Now for delta t, which is down here, when we went from point 1 to point 2, the value of time changed from 2 to 5. So we're talking about this piece. And this corresponds to the distance from, or the time interval from 2 hours to 5 hours. And we call this delta t, change in the value of t. Now, of course, P2 has coordinate y coordinate or d coordinate of 500, and P1 has a d coordinate of 200, and delta d will be 500 minus 200. That would be the d coordinate of point 2, which is d2, minus the d coordinate of point 1, which is d1. So delta d is equal to d2 minus d1. That would be 500 minus 200. Delta t is the t value of point 2, which is 5, minus the t value of point 1, which is 2. So 5 minus 2, or 3 hours. And that comes from here, 5 minus 2. So delta t is equal to t2 minus t1. This is t2, final time. This is t1, initial time. So our t1 d1, so that means that we can now write down, instead of delta d, we can write down d2 minus d1, and instead of delta t, we can write down t2 minus t1. Now, of course, the d2 and the t1 and d1 are the t and d coordinates of point 1. So t1 is 2 and d1 is 200. You notice that t1 is here, the time value for point 1, 2. And then d1 is the distance that we have driven at point 1, which is 200 kilometers. And similarly, 5 is t2, the time coordinate of point 2. And 500 is the d coordinate of point 2, which is 500. So we now put these values into the formula. And m becomes d2 minus d1, that's 500 minus 200 on top, and t2 minus t1, which is 5 minus 2 down here. Now we simplify the top and the bottom, and so this means that in 3 hours, that's delta t, in 3 hours we drove 300 kilometers, that's delta d, which is this piece. We drove 300 kilometers in 3 hours. And when we divide them, we end up with 100 kilometers per hour. Note that the unit is the unit of the top, kilometers, per the unit of the bottom, hours. And the significance of slope is that it's the speed of the car. Okay, now let's take up some common questions about slope. First of all, it makes no difference which 2 points you pick. The value of slope will be the same. As an example of that, if I pick these 2 points, I end up with 300 kilometers in 3 hours. And so 300 divided by 3 is 100 kilometers per hour. If I pick 2 other points, let's say I pick point 2 now at 6 and 600, and when I find the difference, 600 minus 200 is 400 kilometers, and 6 hours minus 2 hours is 4 hours. So I drove 400 kilometers in 4 hours, and the slope is still 400 divided by 4, or 100 kilometers per hour. You see, 300 kilometers divided by 3, or 400 kilometers divided by 4. They're both 100 kilometers per hour. I can even pick 2 points which are close, 1 hour apart, and in that hour I drove 100 kilometers, and the slope is 100 kilometers divided by 1 hour, which is 100 kilometers per hour. So again, it makes no difference which specific 2 points you pick, the slope will be the same. Now, note number 2 is that it also makes no difference which point you call point 1 and which one you call point 2. As an example of how that works, let's take a look at these 2 points. This one is right now point 1, and this one is point 2. And after we find the slope, we'll talk about what happens when you switch them. So for point 1 and point 2, the change in t will be this distance going forward, and because it's going forward, it's a positive value, 4 hours. So we go from 2 hours to 6 hours. And you notice that the distance also increases. So we go from 200 kilometers to 600 kilometers. And that also is positive, 400 kilometers. We covered 400 kilometers. And now slope is 400 divided by 4. This is positive divided by positive, which means you get 100 kilometers per hour. Now let's switch the 2 points. So now point 1 is up here and point 2 is down here. We are going from point 1 to point 2, so here we have to go back along the x-axis, or the t-axis in this case. So we have to go back 4 hours. That corresponds to negative 4 hours. And then we have to go down, and therefore again we get negative 400 kilometers. And the slope is negative 400 divided by negative 4. And it still turns into positive 100 kilometers per hour. So you notice that again, it makes no difference whether you go with these 2 points, in which case you end up with 400 kilometers divided by 4 hours, which is 100 kilometers per hour, or if you switch the order of the 2 points, and now you have negative 400 kilometers in negative 4 hours, which when you divide them, you end up with 100 kilometers per hour. So again, the order of the 2 points makes no difference. The value of slope remains the same. Point number 3, a positive slope means that the line rises as we go from left to right. So this is an example of a line that is rising as we go from left to right. And in this case, let's say that we pick 2 points, point 1 and point 2 here and here. The change in x going forward is positive, and the change in y, because it goes up, is also positive. Now if we switch the order of the 2 points, let's say we pick 2 other points, point 1 here and point 2 here. So these are the 2 new points now. Now we have to go back from point 1 to point 2. So delta x will be negative, and because y also goes down, delta y will be negative. Now slope is change in y divided by change in x, and whether you divide positive by positive or you divide negative by negative, you end up with a positive slope. So the slope of a line that rises as we go from left to right is positive. A negative slope means that the line goes down as we go from left to right. An example of that is this line. Now here, let's pick 2 points, point 1 and point 2. Now you notice that going from point 1 to point 2, x increases, so it's positive, but y decreases, and that one is negative. You can change the order of the 2 points. Let's say point 1 is here and point 2 is back. Now going from point 1 to point 2, we have to go back along the x-axis, and therefore we get a negative value for delta x, but y goes up, so it will be positive. Now again, slope is change in y divided by change in x, so you either end up dividing negative by positive or positive by negative, and so in both cases the slope will be negative. The slope of a line that goes down as we go from left to right is always negative. If you have a slope that's 0, it means that the line is horizontal or flat. So here we have a line here, and you notice that whether I pick my points like this, in which case change in x is positive and change in y is 0 because we're not going up or down. Or you can even change the order of the points, in which case change in x is negative and the change in y is still 0. Going by the formula m equals delta y divided by delta x, delta y is 0 in both cases, and whether you divide 0 by a positive number or 0 by a negative number, you get 0. So a slope of 0 means the line neither goes up nor down, and it's flat and horizontal. And there is one more case. If your slope turns out to be undefined, the line is vertical. Now I'm going to leave this one to you. Just as I did with lines going up and down and flat lines, you should draw a vertical line, pick 2 points on it, find out what delta y and delta x are, and divide them and see what you end up with. You should end up with an undefined expression, which means that it doesn't really make sense to talk about slope when your line is vertical. And that should make sense, because you see, the concept of slope is about how y changes when x changes. For a vertical line, x cannot change. X has a fixed value, and therefore delta x will be 0. No matter what 2 points you pick on a vertical line, they have the same x value. And because x cannot change, it doesn't make sense to ask how does y change when x changes. Well, x cannot change, so that question is pointless, meaningless, and the slope turns out to be undefined. This is actually fantastic that math can catch that kind of a situation where the question is sort of like meaningless and the mathematical model becomes undefined. Okay, let's do one more example before we end this video. We want to find the slope of the line capital T is equal to 273.15 plus lowercase t. Now, I've talked about this equation many times. Just in case you haven't seen the previous videos, this equation relates the value of temperature in degrees Celsius, that's lowercase t, to temperature in kelvins, which is capital T. We want to find the slope of this line and discuss its significance in the context of the problem. And now, so we begin with 2 points. I'll let you check my work. I picked the values 0 for x, or 0 for lowercase t, and also 0 for capital T. In fact, what I did is I found my intercepts, which, as I mentioned in the previous video, would be the best options if you want to graph a line, because intercepts are usually important, and if you have to find 2 points to graph your line, why not find the most important points, which are the intercepts? So I picked 0 for lowercase t, and then I solved for capital T, and I got 0, 273.15. And then I picked the value 0 for capital T, and I solved for lowercase t, and I got negative 273.15. And now with these 2 points, I will these are now my T1, lowercase t1 and capital T1. So when temperature is 0 degrees Celsius, it's 273.15 kelvins. And these other 2 values for point 2 are T2, lowercase t2 and capital T2. With lowercase t2 being the temperature well, the coldest possible temperature that you can have in degrees Celsius, negative 273.15 degrees Celsius, and that corresponds to 0 kelvins. Now with these 2 points, I will start the solution. So slope is equal to change in the dependent variable divided by change in the independent variable. And so that becomes capital T2 minus capital T1 divided by lowercase t2 minus lowercase t1. We put the values in capital T2 minus capital T1, that's 0 minus 273.15 on top. And then for the bottom, lowercase t2 minus lowercase t1, which is negative 273.15 for t2, and then minus 0. And then we simplify the top and the bottom and work it out to get 1 Kelvin per degree Celsius. And you notice the unit here, again, we have the unit of the quantity on the top, which is in kelvins, per one of the bottom, which is in degrees Celsius. So what this tells me is that every time temperature goes up by 1 degree Celsius, it goes up by 1 Kelvin. And this means that the units of temperature are the same. In fact, more than that, as I just mentioned, not just that the units are the same, but they both increase and decrease by the same amounts. Okay, so you can see the significance of slope. Slope, usually when you try to make sense of it, has some kind of significance. In the previous problem that we just did, slope turned out to be the speed of the car. In the case of this problem, slope turned out to tell us that the size of the units of temperature are the same, and they both increase and decrease by the same amounts. Thank you very much for watching this video. In the next video, I will talk about the graphs of the basic relationships: direct superposition, inverse superposition, direct proportion, and inverse proportion. Take care and see you soon.